for such type of studies, and there are enormous application in civil and water resources engineering. So we will going to see some of uh, these technology in detail. So before I start, I would like to mention here that this GIS subject is a very vast topic, and it is also not possible to cover everything in one session. So, to my knowledge, Dr. Shovan will arrange a separate workshop for hands-on training, exercises, and several other module. But here, my idea is to make your fundamental or concept very clear to each one of you. And I have divided this lecture into four module. This four module lecture comprises of fundamentals of GIS, which would be my main focus. And if time permits, I will introduce QGIS and ArcGIS to all of you, and I will also going to give you some exercises. Uh, as In the interest of time, it would be not possible to you to perform the experiment in here in this setup. But I will be going to give you some raw data, as well as I'll tell you the suitable tutorials where you can explore more. So let us start with this. So I will be mostly focusing on module number 1 and 2, which is on fundamentals of GIS, different application of civil engineering and water resources engineering, and some hands-on introduction to both QGIS and ArcGIS. Well, module 1 comprises of fundamentals of GIS, which is so if we talk about fundamentals of GIS, you must know the different components of GIS, different attributes of GIS, types of GIS, application, several models, softwares, and how, as a civil engineering students or professionals, how you will going to apply this knowledge for in your own domain. So let us understand this term fundamentals of GIS. Sorry, it was disconnected. Am I audible?
Yes, you are audible.
Okay. Can you tell me which part where it stopped?
It's top here only. The screen which is visible. Geographic.
Geographic?
Yes, geographic.
Okay, okay.
First point only.
Yeah. So I'll again repeat. This is challenging in online mode. Sometimes presenter doesn't know about the active online or not. Okay. So here, geographic. I was talking about geographic. So most of the data collected is associated with some location in space. Some of the example which I have already narrated is related to, say, for example, smart cities. So for smart cities, there are several attributes and components. For example, identifying the suitable location for placing water distribution network, distribution of pipelines, distribution of several other components related to sewer system. Also, identifying the suitable location for groundwater potential zone, vulnerable zone related to water quality, landslide zone, and so many other applications of GIS are there. One can also identify the suitable location for uh, road, road network, location for lake, water bodies, and so on. Okay, so this is called geographic. When we say geography, uh, it it deals with location which is having latitude and longitude. The second part of GIS, which I stand for, information. Information here is attributes. Attributes are the characteristics of the data that can be used to symbolize and provide further insight into a given location. For example, observation well or bore well or dug well. So dug well uh, has would have several information. One information of bore well or dug well would be latitude and longitude, the name of bore well. Could you tell me what are the different attributes associated to any well? You can write in chat box. I request students and participants to write this information. Are you following what I'm saying?
Yes, Chandan.
Yes.
Yes, Chandan.
Okay.
So you have heard what the resource person has said. You have to write it down. Okay, then only you will follow.
Right. So one, I'm getting echo. Dr. Shravan, can you unmute?
Unmute.
Okay, thank you. So yes, one of you you have written groundwater level. Uh, the other response is depth. In addition to this, groundwater level and depth, two I have already told you the name of that location could be well ID is one of the attribute. Groundwater level or depth could be one another attribute. Latitude and longitude would be another attribute. Contour marking. Well, contour mark.
Chandan, your screen is not visible.
Sharing is not. Screen is not shared.
No, I have not shared my screen. I am just looking at the chat box.
Okay, okay.
Yeah. So one of the response is contour marking. Contour marking. Okay, I'll modify this response. Instead of contour marking, you can say elevation. Elevation of that location, that particular well, with respect to mean sea level. That could be one attribute. In addition to that, if it is observation well, you can have n number of water quality parameter for that particular location. For example, pH. Should I say, or you have to write? There are n number of physical properties, chemical properties, pH, TDS, dissolved oxygen, chloride content, magnesium, metals. Okay, n number of water quality parameters can also be associated to that particular location, and these are the information. Okay, so what two things this has? The one thing is the geography, and other thing is information, right? Please confirm whether my slide is visible.
Yes, it is visible.
Okay, so the other hello. Uh,
Now it is audible.
is my voice audible clearly?
Yes, clearly it is audible, and your presentation is also visible.
Okay, thank you. Yes. So here you can see the third component was system. So system is basically a computer, network or hardware, which which has linkage of this geography and information. So together it is called GIS. So GIS is nothing but a computer-based system for the collection, storage, organization, maintenance, and analysis of specially referenced data and the output of specially referenced information. Here I request all of you to remember this word, specially referenced data. This is important, and I will elaborate and explain this in detail in coming slides. So this GIS is nothing but a system where it can store the data, analyze the data, compute the information which has some reference, especially referenced data. Okay, so data could be any collection of related facts, basic elements of information. Just now I have told you the example of bore well or observation well. Okay, so that is data. Information, data that have been processed to be useful, that provides answer to who, what, where, when, all these questions. So who means what? The nature of data. What, again what, type or kind of data. Where means again location. When it is associated with time. Okay, so you may also associate things with time. For example, one of you have written, Puneet has written groundwater level data. So groundwater level data could be associated with frequency of monitoring, could be monthly data, could be quarterly data or daily data or annual data. So time series could also be reflected here with information. So information can only come from accurate data or sources. So there are several agencies who monitors the data, who are custodian of the data. So one can obtain from data from that authentic source, or research laboratories and other organization also collect some of the data for their own research purpose. GIS history. So here geographic technique, as I mentioned, previously the computer was not there, so people used to draw drawings by hand. So before the 1960s, people used to draw all the maps with hand, which has geography, which has location and attributes, but it doesn't has any linkage with computer. Okay, so this the first GIS which was introduced was Roger Tomlinson in 1960s, and it was operational. He was from Canada. The operational it was become operational since 1970s. Then US government organization called USGS, United States Geological Survey, has also introduced this GIS later on in 1970s. So Edinburgh in 1970s came up with MSc GIS. Harvard Computer Graphics and Spatial Analysis Laboratory also introduced in 1965. Similarly, ISRI introduced this GIS in 1969, which was environmental consultancy firm, and they have come up with several variants of GIS. The first variant was Arc Info 1982, followed by Arc View desktop version 1995, and Arc GIS 1999. And thereafter, n number of companies, the organization came up with different versions of software which uses GIS. So Map Info was also introduced, Quantum GIS was also introduced, and these are all different versions and types or variants of different types of software. Well, the recent or advanced version is WebGIS, okay, which work on server. Also, you can familiar with Google Map. Google Map is also one of the widely used application of GIS. Everyone familiar with Google Map? Google Earth also you know, and OpenStreetMap is also very openly available. So let us understand this three to four kinds of GIS. Okay. So one of the kind of GIS is desktop application based GIS. So what do you mean by desktop application? Like as you are installing software on your system, so that is nothing but desktop based application. For example, you are using Microsoft Word, PowerPoint presentation, AutoCAD, and n number of applications you are using, which is being installed on your computer desktop. So that is desktop based. So GIS, when it was introduced, it was desktop based, and still a lot of desktop based application is available. So one of the desktop based application software is ArcGIS and QGIS, which is widely used. Another kind of GIS is web mapping or feature or server GIS. So this server based GIS is the information, instead of keeping in computer or desktop, it has been kept in server, okay, through cloud. So that is nothing but server based GIS. The another kind of GIS is web browser GIS with class children. Web browser with GIS tools, thick. So this web-based web browser with GIS tool is what is GIS, something where one can browse with web and use the GIS tool instead of installing inside your either desktop or any other or server. So one of the application of this is Google Earth. Okay, Google Earth Engine is also one of the example of web browser based GIS tool. Then applications, mashups, APIs, distributed GIS. So all these are several applications of GIS where one can develop either on desktop or web, and then it would be published into public domain for several uses. For example, as I told, Google Map is one of the example of app-based GIS, which is freely available on Play Store. The other, if you look at Zomato, Swiggy, Blinkit, or n number of application, Ola, Uber, so these are also a several application of GIS, which is of fourth kind, which is app-based GIS. As I told you, you can see on your screen Google Earth. I don't know how many of you are familiar with Google Earth. Are you familiar with this? Please respond. If you are familiar, then uh, then respond. Yes. Okay. So Google Earth is also one of the application where you can explore several features associated with location, GIS based features. This I will also going to talk about this in some moment. So let us understand with fundamentals. So as of now, what you have seen, now you understand what is GIS. So there are some fundamentals that you need to understand. And if you know this fundamental, then you can able to apply this GIS tool for your own purpose, either for project, either for some consultancy purpose, or either for research or R&D purpose. So it has four parts. The first part is data. So before you understand GIS, you must understand what are the different type of data which could be used inside this GIS. Second part is management of data, management of information, that you need to understand. Science behind this, very important. So before, see, one cannot go blindly and go for using this application. You need to understand the science or mathematics behind it, and then you can able to apply. And one most important thing is decision. So decision is again case to case, it varies depending on the type of problem. uh, this decision can vary. So the decision would be, say for example, my purpose is to establish a rooftop rainwater harvesting system in a given location or in given system. So I need what? I need data, I need management, data management. I have to apply some science, some mathematics, and then I have to come up with some decision. For example, suitable location to install rooftop rainwater harvesting system, which are all associated with GIS, as well as which has these four components. So let us understand this four components one by one. GIS data. GIS data, we will here going to see what are the different types of data and file formats. So once you have familiarity with data type and file formats, you will be in a better position to apply GIS. So broadly it has two types, vector and raster. So vector has again three types, points, lines and polygons based on geometry. These are special features. Having special feature means what? Information related to space. Tabular attributes means the information which can be arranged and written in tabular form, as you write in either Word or Excel sheet. Raster is nothing but pixel. What do you understand by pixel? Pixels are nothing but arrangement of different location of features present on the earth, either on rectangular as well as square grid. The best example of your pixel is your own uh, the picture which you grab from mobile phones. Okay, it has made of several pixels. Satellite data also has several pixels. So we'll see one by one this type of data and information. Well, so vector data are defined especially point, line, and polygon. So when we say point, a point is nothing but a pair of x and y coordinates, either lat or longitude. Okay, so x1 or y1 has some information in the form of coordinates. So that is called point. Example of point data, as I have mentioned, observation well. Would you like to add another example of point data? बताइए. Any point data other than observation well? You can write in this message box. Am I audible to all of you? Am I audible? Hello? I don't know whether I'm audible or hello. Okay, if I'm audible, then I request you to uh, either you can open your mic and respond, or you can write. All of you have to actively participate. I understand that it is post lunch session, but you need to respond. Otherwise, it would be a one-way talk. Yes, students. Should I repeat my question? Hello? Should I repeat my question?
Yes, you can.
Okay, repeat. So my question was, we were discussing the vector data.
In vector data, we were discussing the point, line, and polygon. One example of point data I have given, observation well or dug well or any well. So I want one more example from your end in addition to observation well. Understood? Yeah. Okay, I'll tell you one more example. Then you can add. One example is, say, electricity pole. If you look from the top view, you will have electricity pole where you can locate the the locate with the point. Okay. Any other? Telecommunication tower is one. Tower crane could be, yes. And there are several landmark features. Okay. Could be hospital building, just the location of your own building. It's only geographical location I'm talking about. Okay. Major locations, landmarks, site of importance that could be located with points. Okay, moving on. There are line. So line is again a sequence of points. So sequence of points mean what? Several nodes, x1, y1, y2, x2, and so on. So आप कौन सा geographical feature आप line से represent कर सकते हो? River, road, drainage line, sewage line, sewer line, okay, railway line. So there are n number of features you can represent by line. Similarly, polygon. Polygon is a closed set of line, okay, or network of lines. So network of lines can be represented by the boundary of building, the boundary of organization, the boundary of your own building, Durgapur, the boundary, the boundary of watershed, okay, the administrative boundary, village boundary, city boundary, country boundary, water bodies. There are n number of features which you can represent using polygon. Okay. So there is a see, the idea is to represent the feature which is present on the earth using either by point, line, or polygon. But as I have mentioned, there are two types of data: vector data, raster data. So raster data can be represented by point, line, and polygon, whereas raster data can be represented by pixel. So for 1 point, 1 pixel; for line, series of pixel; for zone of cells, it could be matrix of pixel. Okay, for polygon. So these are three basic features, three basic type of data, both for point, line, and polygon. You can represent. I hope you are following this. Concept of vector and raster. So concept of vector and raster, if you look here at the real world example, say on the figure on the top, you can see there is a river, there is a house, and some features like tree, for example. Okay, so it could be represented by in vector by point. This drainage or river can be represented by line, or some other features can also be if it is compound wall, can be represented by polygon. Similarly, here one can represent the same information in pixel format, with each pixel having the information stored. For example, that T notation is belong to tree, for example, H is for house, and R is for river. Understood? Okay, so what types of data are used in a GIS? First is coordinate data. connection information, descriptive information, temporal information, images, documents, and URLs. So these are all possible type of data that can be used in GIS format. Coordinate data. So coordinate data are the data where you can attach coordinate information. If you remember, I told you that when I was describing the definition of GIS, there was one terminology called spatially referenced data. So spatial data is that data which has coordinate, which is either X or Y, or one can represent it with latitude and longitude. So that is here in this particular map, you can see it is 2D map having X and Y information stored. Here is the 3D map where you have X and Y information as well as the elevation. Okay. File formats. Well, before I start this, what are the different file formats? Do you know? Can you type or open your mic and say? One example is, say, Word file. Word file has some format, say .doc. Similarly, there are n number of files. So can you write down? Yeah. .pdf is one of the file, or Revit .rvt. Any other format? ppt, .ppt, .pptx. For Notepad, you have .txt, .dwg, yes, for AutoCAD file, .csv for spreadsheet, XLX or XLS is also for Excel file. Okay, and there are n number of file type which are available. Okay, similarly, GIS file also has some file extension that we will going to see the file format. Okay, so first understand shapefile. Shapefile has 3 to different types of files. Okay, one of such type is .shp, which denotes geometry. DBF, which denotes attributes. PRJ, which denotes projection system. You remember this word? I will explain what is projection system. All right. So geodatabase is also one of the format. The extension for this is .gdb. It can store all the files related to vector and raster at one place. Coverage, vector or grid. It also has this older format. Nowadays it is absolute, but still some module or software has this. So here is the all file format for both vector as well as raster. So collection of files with .shp, .shx, .dbf, prj, and some other extensions are also available. Those who are familiar with Google Earth, the file extension for Google Earth is normally, you can see, KML file, .kml. ISRI geodatabase is .gdb, and these are not only limited to, but the above one is on your left is widely used file type for vector type of data. Similarly, raster also has many. Some of them I have listed here which are widely used. One is .tif, TIF. So you may also find .tir, .jpg. You might be familiar with this .png, .img, and so on. Okay, so these are the commonly used file format both for vector as well as raster. Okay, so this is all about data or type of data or file format. And let us understand the other part. Okay, management. So there are n number of data available. Say for example, for a given piece of land or watershed, there could be a number of layers or information associated with one object. Say for example, places can be represented by dots here on the top. On the second number, there is a highway on the same map. Highway. Census map could also be prepared. Hydrography map consists of different drainage network. Topography map consists of elevation of that area with respect to mean sea level. And in addition to that, there are again several information available which are associated with particular location. So the question is how to handle these data. So these data is being handled using software having attributes. So that attributes you need to understand and what features it has, like whether it has multiple attributes or attributes of point, line, or polygon, whether it has single attribute or multiple attributes. Okay, so that you first need to understand, and based on that you can combine it. Combine means what? It is an operation to combine the different file format with a single file format. That is nothing but overlay. Okay, so one can convert, either you can convert raster to vector or vector to raster, and then you can combine together easily. Okay, like for example the previous example here, you can see the topography map is raster and rest of the map is in vector format. So either you convert everything in vector or everything in raster and then use it for some purpose. Okay, vector, and the process is called as vector overlay. So vector overlay is the process where you can combine either vector layers together or either the raster layer together using some mathematical operation, either intersection or through union and so on. Okay, I'll tell you the example of that also. So that is all about management, managing the data. So let us understand the science behind it. Well, the science is limitless. There are many things, but few things I have worked out where I feel it is important to you for to remember this concept. The one of the very important concept is coordinate system. Okay, coordinate system. When we say coordinate system, it is a system that uses numbers or coordinates to determine the position of a point or geometric element within a geographic framework. For example, आप सबके पास आई कार्ड है. You all have your I card, Aadhaar card, or someone may have PAN card. Okay, so what is written in those identity card? Your identity, personal identity, your name, your, if you are a student ID, if you are faculty or some professional, employment ID, if your mobile number, your either office address or home address, so that, and your photograph. So these are what? These are the attributes which are associated with you. Similarly, when you look at the real world, the surface of Earth, it also has some information stored, which is in the form of latitude and longitude. So each and every inches of Earth surface has some information stored, and mathematically or scientifically, over a period of time, it is recognized as a system that is represented using latitude and longitude. Okay, so this allows geographic data set to use common location and integration. Okay, so a coordinate system is also used as a reference system to represent location of geographic features, observation with respect to some position, with respect to some benchmark. Okay, so the simplest coordinate system consists of coordinate axes oriented but perpendicularly to each other, known as Cartesian coordinates, which you have studied in geometry. So depending on the type of problem under consideration, a specific type of coordinate system can be used for better understanding. Okay, before I explain this example, let me explain this simply. Uh, Here I'll stop my screen and I'll switch on my camera. Okay, so I'm visible to all of you. Yeah. So let us let me give a simple example. Say for example, here is uh, say for example, this one is a globe. Okay, this is globe of oval shape. Okay, spherical shape, right? And if I want to know the dimension of this globe, what I can do, I can measure it using tape, or if I have to, but this is in 3D format. सर लेक्चर में सर आ जाइए सर. हाँ मैं लेक्चर में था. हाँ आ जाइए. Okay, so this is having a global a globe. Okay, Earth surface. So if I want to prove the mathematically the location of it, so this is in 3D format. So in 2D format also I can get the location, linear distance. Okay, how? I can simply open this. Okay, and I can make it a 2D like this. Okay, this is 2D, right? This is a 2D. So similar concept has been applied in for this geographic system where you have an angular unit in for Earth surface, which is globe, and one can transform that unit, angular unit, into linear unit. So the demonstration just now I have shown you is nothing but transformation of angular unit of 3D into two-dimensional unit. So that is why whenever you see the latitude and longitude, it has two unit, angular unit as well as geographic unit. So angular unit consists of what? It is horizontal and vertical. Okay, and here you can look at this the graphics where you can have the 40-degree west with respect to 40-degree north. This is angular unit, and this angular unit has been transformed at the same location into a two-dimensional unit where you have decimal units. Okay, so this is called nothing but projected coordinate system, right? So in GIS, these two basic system has been enormously followed, and Similarly, let us understand this geographic coordinate system. Just a minute. So here is the example of the use of lines and latitude and longitude. Any location on the Earth's surface, you can represent by intersection of longitude and latitude by line, and from point you can represent it by using longitude and latitude. Here is the example where you can look at the position of Earth's surface in decimal as well as the degree. Okay, let me demonstrate it again using Google Earth. How many of you have installed Google Earth? Do you have Google Earth installed with you? Not yet. Okay, so those who have not installed, I request to install. It is free tool. Google Earth Pro, I would recommend to install. Those who are working with those who wants to work with GIS, it is very important tool. Okay, so let us search BC Roy College, Durgapur. Okay. Is it visible to all of you? Okay. So here you see this is your institute, and here if I want to know the location of this particular, say for example, this is your administrative building. Okay, I do know I'm not familiar with your administrative building, but okay, it is written auditorium hall. So this is your auditorium hall. Okay, and I want to know the latitude and longitude of your auditorium. So what I will do, I'll just add here place mark, and I'll move this place mark at this place, and I can see exact latitude and longitude of your location. Okay, where you can see the latitude is 23.5 and longitude is this. Okay, and there are several way I can look at this. So the other way also you can, if you want, if you wish, you see here or at the bottom right, here it is written lat and long and elevation and eye altitude. So here if I move this cursor, this lat long will also changes. Okay, so in this way you can get this latitude and longitude. All right, moving on. So this entire system is called CRS, Coordinate Reference System, where it has two types. As I mentioned earlier, angular units and linear units. Angular unit is degree, minute, second, and linear unit is having decimal degree. Spherical units, angular units, flatter plane. Okay. All right. So this is all right. So one more thing. This is very important. There is entire, as just now I have demonstrated that entire globe is being transformed or projected into angular unit to the linear unit, where one can have the 2D view And now, if you look here as world UTM zone, it has several zones. So entire globe has been divided into some zone. Okay, so this zone is you can see here the entire globe, and let me see for India. So uh, India has this much zone UTM. UTM stands for Universal Transverse Mercator. Depending and here you can look at the West Bengal. West आपका दुर्गापुर बताइए कौन से जोन में आ रहा है? Anyone? Open your mic and say. Okay, first I will tell my location first. I am located here in Chhattisgarh. Okay, this is the map of Chhattisgarh. I have here UTM zone. Which one? 44. So 44 is my UTM zone. What about you? Yes, UTM 45. Right. So UTM 45 is your zone. So this is all about a little science, and I said word little. There are many aspects, many things, but I found this is very essential for all of you to know and understand before you start working on GIS. Okay, so as of now, what we have discussed: data management, science. So let us see about decision. So here in decision, say for example, I have one watershed consists of digital elevation model, watersheds boundary, different sub watersheds. I hope by this time everyone understood watershed. Watershed is that location where the a particular geometry or area has been divided based on the surface drainage condition and rainfall characteristics. Okay, streams, the river, and water bodies. If I need to combine this, I have to use overlay operation. Either I have to combine this, combine everything uh, mathematically. So before proceeding mathematically, either I have to use vector or raster. So everything here is not raster because watershed boundary, stream, water bodies are in vector file, and this digital elevation model is in raster. So ideally, this has to be converted into raster. Okay, and it could be combined further. So once you combine it, you have some meaningful result where you can see the location of river, location of water body together, the sub watershed boundaries, and the location, drainage location. This is just a simplest example of integrating raster and vector database together. There are n number of application for this. Okay, so like for example, you can ask and answer several questions like which district has the most town. If you have like on your figure on your right, you can see there is a polygon, and polygon has some dots points, and that points represents the town, and polygon represent the district. So one can count that how many uh, district has the most town. Then one can also count the number of points in each district and then say about that particular district. In which district does this town lie? So there are several questions. So all this question can be answered manually or could also be smartly answered using GIS tool. Well, overlay, just now we have discussed this. I'll skip. Well, another data model based on inventory of data layers. So say for example, for a piece of land, you have this data set called stream, hydrographic unit, drainage area, hydrographic channel, surface terrain, rainfall response, digital orthophotography. So you can combine this information and get meaningful outcome. And there are several ways you can represent the map and convert the map into graphics. How does GIS answer special question? So there are several ways that GIS can answer special question based on query. So query is that input and edit both spatial and attribute data. You can generate the query and get the answer. You can display the data on screen and print a map, analyze the data and making decisions, searching for the patterns and so on. Right. Well, this is the map which I have generated. This is just for demonstration. I may also explain how to generate this map using either ArcGIS or QGIS, but time is limited, so I'll skip this. But definitely, I will going to demonstrate one exercise how to generate such type of maps. Okay, so here is the map of India, where my study area was located in the central India. This is the Vidarbha region of the Vidarbha region of Maharashtra, consisting of several geological features. Okay, what type of questions can be answered by a GIS? Where are particular feature found? What geographical pattern exists? Where have changes occurred over a specified time period? Where do certain conditions apply? What will be the application if an organization takes a certain action? Application of GIS. N number of application. You name the discipline, it has application. For example, urban planning, management and policy. It has zoning, subdivision, planning, land acquisition, economic development, code enforcement, housing renovation program, emergency response, crime analysis, tax assessment, environmental sciences, which also has n number of applications, which is directly or indirectly related to civil engineering applications, groundwater modeling, contamination tracking. Political science also has redistricting, analysis of election result, predictive modeling. Civil engineering utility like locating underground facilities, designing alignment of freeways, transit, coordination of infrastructure maintenance, business, education, real estate, healthcare, and so on. This is not the only application. There are, in addition to this, there are n number of applications which GIS has. So what GIS application do? It manage, analyze, and communicate. The main purpose of this application is to communicate. It is for utility purpose. Okay. So how it will communicate? The best way to communicate is through graphics, through map. So the ultimate output of any GIS analysis will be product of map. Like as I have shown here, this is a location map of a study area where you can see the index map of India and neighboring countries, and study map of India where you can see the geological or aquifer features present in that particular region. Modeling. So there are several models available, GIS based model, conceptual model, mathematical model, data model, spatial model, computerized spatial data, and so on. And there are several architecture of this GIS system, which include data input, geographic database, transformation analysis, display and reporting, query, input data. So those who are feeling that it is going fast, this is just for your exposure. What are the different features of GIS is. Okay, I'm just giving you the glimpses of GIS and its various applications and capabilities. GIS model, it has latitude, longitude, roads, hydrology, topography, several features, attributes, layers information, and several other applications associated with allied branches of civil engineering. Well, it has raster model, vector model. Raster model has its own application where you have arrangement of different pixels of either equal size in square or rectangular size. Vector model has its own advantage which is arranged either in point, dots, nodes, or lines, arcs, areas, polygons, etc. These are some example of images and smart GIS data. A few more examples of network of roads, overlay based on common geographic location, analysis. Okay, one analysis is, say for example, a piece of land where uh, there is a possibility of having some incident, or this is a hospital location at particular site, and the task is that within a half mile one can reach to that particular facility. It could be hospital, it could be hotel, it could be institute, it could be any other public utility component. So for that, the complete area can be digitized using polyline, line, attributes. Then one can calculate the distance between the objects, and based on that, one can identify the suitable location and its optimum path from your origin and destination. So you can enter your origin, your lat long, and another destination, and you will get that facility. For example, the thing which you work with Google Map, what you enter your origin, your current location, and destination where you wish to go. So on interface, you are writing the name, but in the back end, that name is associated with some latitude and longitude, and that latitude and longitude, with the help of that, one can the map can estimate the distance and time, and they will also give optimum route or optimum time. Okay, so based on traffic condition, you can decide which pathway you have to go, and so on. So that is the whole path analysis is called as network analysis, and there is algorithm called Dijkstra's algorithm. So that Dijkstra's algorithm, one can solve and identify the optimum path, and whole such type of applications are originated from Dijkstra's algorithm, where if you look at any app, whether it is Ola, Uber, or Swiggy, Zomato, or any other app, what they does, you have to select some facility. Say for example, you wish to order fish curry. Okay, so you can enter fish curry, you can search location, your own location, then you can select some restaurant or hotels, and then you write down the destination of your restaurant and facility. So what this software process, they take out all the GIS attribute associated with that location. So what they will process, they will first go through object ID, they will then assign the latitude, longitude, and they will assign the facility which is associated with that, and the network will optimize the path, the time, and ultimately the delivery of that particular product. Okay, similarly, the Ola also works in the same way. The product is the vehicle which will come at your location. Okay, and so on. So all such application has this GIS feature: distance, time, and location. Well, these are all has vector layer and attributes. Vector GIS. Okay, coming to the software. So which software has to use? So there are n number of software in market is available. So I don't know whether I'm audible to all of you or not. I have to check my internet connection. It's working? Yeah. Software for GIS. So vector-based GIS and raster-based GIS. You can see the name of the GIS and remote sensing software which is available, commonly used, and there are other popular software which are there. So as I mentioned earlier, the history of GIS. GIS started at universities as a research tool at several Harvard, Yale, and other university, and it has been evolved with variety of different capabilities and tasks. Among this, I would suggest you to use open source software. So one of the open source software is this QGIS. But among all these, one of the widely used on popular software is ISRI ArcGIS. So either if in your institute, either you can purchase the license of ArcGIS, it is costly, or one can go for QGIS, which is freely available. In previous class session, I told you to download this QGIS. We will see some of the features of QGIS. So open source GIS is this. These are the list of open source GIS software. This is web-based GIS. It is very important and very useful. One of the widely used application of web-based GIS is Google Earth Engine. And one application I just now told you, Google Earth. Okay. So Google Earth Engine is very strong tool based on JavaScript, and it is very, very useful for computing a very high resolution satellite data. Without downloading any satellite data, you can compute and does a lot of different analysis. Okay, so this is all about web-based GIS. And before I say thank you, I will introduce QGIS to you all. So still we have couple of minutes left, or 5-10 minutes I can spare more. So whenever you open QGIS interface, it looks like this. Okay, so here these are for any software. If you open it, it has few common features. Like for example, here at this middle, you have working space. On your left, you have different layers where you can browse the layers. You can add different layers. And on your right, extreme right, there is a toolbox having different commands where you can access that command directly. And above these screen, there is a menu option where you have different options as other software has, where here you will going to use three options very often used. You will going to have one is vector toolbar and another one is raster toolbar. Just now I have discussed about vector and raster. Okay, vector data and raster data. So vector data, if you're working with vector data, you have to use vector. If you are working with raster data, you have to use raster. Well, the project file is the file menu. In most of the software, you have file menu. Instead of file, here you have project, where you can create a new file, new project, open the existing project, save the project existing, and you can also import a lot of other imageries. Okay, so this is all about QGIS. Here I will going to demonstrate a simple exercise where I'll demonstrate how to create a map. Just now I told you a simple map which has been created. Like where it was here. This is the map. So similar one simple map I will create, and then I'll going to give you some tutorial assignments. Then I'll say goodbye to all of you. So let us see this. So I have some data I prepared for you. This is the previous from previous session. Okay, so I have certain data set with me. Let me see what data I have. So I have TIFF file. Okay, before moving on to that, let me add one TIFF, one raster file and one shape file. Okay, so first I'll sort this by TIFF. So first I'll import one small TIFF file. And I will also going to import some vector file, which is shape file. It could be road, could be some area, contour, elevation, object, or if I have boundary, I can also add a boundary. Let me see. Raipur. Yes. So this is the map of Raipur district. Here, just go with this flow. What I have done, I have just imported this in my graphic in this layer window on your left, and here I go to property. In property, I'll go to information, and information I'll get a lot of different general information. I have like the name of file is Raipur, path is, this is the path, the size of file. Then there are other file format associated with it. If you remember, I told you that the vector file has several extension. Okay, so that extension you can see dot shx, cpg, prj, sbx, shp, xml, sbn, dbf. Okay. Similarly, this was last modified in 2023. Shape file, you can see the geometry. Geometry type is polygon. We just now we have discussed that types of the vector file. So that file, the type is polygon. CRS, coordinate reference system, also we have discussed. And UTM, you see the UTM zone is 44. And the coordinate system is WGS. Unit is meter and type is projected. And this is the extent of this. In addition with that, you may also look at attribute table. I haven't added any information, so it is showing blank. And this is all about vector file. Let us see raster file. So here is the raster file. I think this is lineament density. Here, if you go to the property information, here you can look at this. This is the name, the path, the size, and the format you see. This is TIFF, GeoTIFF format. Okay. I have told you the raster file, it has several format. So here in this extension is TIFF.tif. Okay. And you will see all the general information, the extent, XY extent, the dimension, the coordinate reference system, and that's it. So this is about the raster and vector file. You may also do n number of operations here. You can change color, do some analysis, but in the interest of time, I will skip this. But I will show you how to export this data, how to create a map. Ultimately, the objective of this type of software or application is to get the, am I audible clearly? Hello. Okay. So here, for this to create a new map, go to new print layout. Say for example, Raipur map, and here you can add map. Here is the map is being added, and you can perform n number of things here. Like for example, for a particular map, there are several features you can add. Say quickly, I will going to add label. So label I can add here at the bottom. I can add legend. This I'll delete. Legend is this. I may also add north arrow. This is also one of the feature of map. This I'm drawing very quickly. So yeah. So this is the scale bar, which is also one of the important component of map. For any map, you should have a title, the north arrow, the legends, the latitude, longitude, etc. And I'll add one more thing, the text. Text I can add, or title. I'll add title. Title I can add here. So I'll write map of Raipur district. I may also add several other information, but I'll limit this to only this type of this features. And once you're done with this, you can export this as PDF. I'll go to that section. Here I can write Raipur map, save as PDF, save it. It is saved. Go to that folder where I have saved it, Raipur map. So here is the final outcome. Okay, it is nothing but a simple map of Raipur, where it has north arrow, scale bar, the title, the labels, some legends. In addition with that, you can also write index map, the location map, you can do some analysis and then create map. You can also add latitude and longitude. So this is a small demonstration of GIS software, QGIS especially. Those who are interested in learning more, I will provide you some link where you can study about it. Say for example, this I will share. This is if you see this QGIS tutorials here, it is provided in on the website of QGIS, qgistutorial.com, where you will find the basics GIS operation, starting from making map. Just now I have show you how to make a map. Say for example, if I click here, it will show you step-by-step procedure to first get where to get the data, the procedure to add the map. Just now whatever I have demonstrated, you will find such option over here. Okay, and finally this map you will get like this. Okay, so this was the map of Japan, Tokyo. All right, so in addition with this, there are n number of, so these are basic GIS operation. Those who are beginner, I'll request everyone to start with this. First, complete basic GIS operation, then go for intermediate GIS operation, then advanced GIS operation, and based on the, you can also develop algorithm and do all such things. Network analysis, hydrology, urban planning, like for smart cities and other stuff. Then Python scripting is also available, PyQGIS, okay, and some appendix, and you will find a number of tutorials, uh, the solved examples on several other platforms. So this is all about for today's lecture. Uh, I will share this link. I think already Dr. Shovan has shared this link with you. Okay, here, let me confirm. Yeah, this is the same link. So kindly tell us the step to prepare this map as summary. Soumyadeep Das. I have already shared, Dr. Shovan has also shared this. So you may use this link. I have pinned it. So before logging off, just let me know whether if you have any queries. If you have any queries or questions, I would be happy to answer. Otherwise, we'll meet some other time. See, there is no compulsion. Okay, you it's your choice. If you have question, you can ask, or you can also write an email or text me a message. So not an issue.
Thank you very much, Dr. Singh. It has been a privilege to have your session.
Okay, I can see one question. How can we use GIS for groundwater modeling? Well, you cannot directly use GIS for groundwater modeling, but you can prepare input maps to start with groundwater flow modeling. So groundwater flow modeling, generally it is a physical based modeling where there are several features which is required for preparation of maps. For example, boundary condition. If you want to set groundwater modeling, you have to have a location map, boundary condition, the aquifer maps. So all those maps, input maps, the grid maps, all the knowledge of GIS is required to make such models. Okay, that's why somewhere I have mentioned groundwater modeling application. It is very useful. I hope I answered this. Okay, so that's all from my side. Thank you all, Dr. Shovan and other faculty members. May I leave or?
Thank you, sir, for this very interesting session. We had a very good experience, and the presentation was very engaging. I thank you on behalf of Civil Engineering Department, Dr. Bisra Engineering College. I wish that we would have some more sessions in upcoming days. Uh, Thank you very much, and we will be in touch. So that's all for today. Thank you, sir.
Thank you all dear participants, students.
Thank you, Chandan.
Special thanks to Dr. Shovan and all faculty members by organizing this FDP program. I wish all the best to all participants and students. Thank you.
The feedback will be shared in the WhatsApp group. So all of you can fill the feedback by today itself. So that's all for today. The next session for tomorrow will start at 11 a.m. Thank you.